Hey there, welcome to a video discussing the 6.2 day one homework solutions. And the assignment, which was posted to Schoology last week, was doing the last 4 pages, numbers 1 through 8, I believe. Sorry, 1 through 6. So remember, we're doing the Gauss-Jordan method, which means that we need to combine rows and to cancel out certain terms. And the whole point is that we want to be able to get some zeros in some of these rows here. So that way we can make a simple equation and then solve the rest of the system. So obviously the number one is a 2 equation and 2 variables. It's actually a 2 by 3 matrix because you have 2 rows and 3 columns. That's the augmented matrix, where the last column is going to be the constants 9 and -6. And of course, see where -4 and 9 are located. Those are x and y respectively. 1 and -3 are also x and y respectively. So what we're doing is that we're putting all this information in the system of equations into a matrix. Once we do that, then our goal is to get some zeros in some of these rows. For example, if I did R1 plus 4R2, so clearly this is R1, right? If I multiply R2 by 4 and add those rows together, what's going to happen is that you're going to see that you're going to have, when I multiply this by 4, for example, it'll be 4, -12, -12, and -24. When I add this with the row right above it, the -4 and 4's cancel. So you get 0, and of course you keep going. 9 plus -12 is -3. 9 plus -24 is -15. At this point, you have enough to actually start solving one of the variables. Because what this means, when you have 0, -3, -15, it means you have 0x minus 3y equals -15. So the x goes away because you have a coefficient of 0 for it. Y would be 5. Once you get that, then you have the top row, which is yet another equation. I mean, obviously, it's the one that we had originally. And yeah, you just do -4x plus 9 times 5 equals 9. Work it out. You get x equals 9. Number 2 is also a pretty simple system. It's 2 equations, 2 variables. And again, you have kind of some freedom of what you want to eliminate. It's up to you. So it's kind of infinite possibilities, but you're looking for common factors or multiples. Actually multiples. That's probably a better way of thinking about it. So for example, what if I did R2 minus 4R1? If I multiply R1 by 4, you get -4, -28, and 56. And you add it, or sorry, you subtract R2 with 4R1, and you see that the first terms go away. They have -14 minus -20, which is +14. Be careful. There's a lot of negatives, so be careful. 28 minus 56 is -28. Now you have enough to solve 14y equals -28. Solve for y, get x, and you're golden. Yeah, another system of 2 equations, 2 variables. In this case, I decided to get rid of the coefficient of x's, but I did 3R1 minus R2. So that therefore, if I multiply the top row by 3 and subtract it with R2, I'm getting 16 and -64 in the second row. And yeah, I get y is -4, solve for x, that's -4 as well. And you can always go back and plug into the system, see if it makes sense. This one's a doozy. You have 3 equations, 3 variables, but you make your augmented matrix, and you could actually do a couple of operations in one step. Like here I did 2R1 minus R2 to get rid of the first term in the second row. And I did 4R1 minus R3 to also get the first term in the third row. And then I decided to combine R2 and R3 to get rid of the -9s. But of course, R3 loses it because I'm doing it. I'm changing R3. So you also have to decide like which one do you want to change. It's up to you. I could have done R3 minus R2 and had R2 altered. So it's up to you. But the way I have it here, I have 6z equals -6z equals 12. So z is -2. Then I could throw it back into the second row, which is -9y plus 7z equals -23. Y is 1, and then solve for x. 3 by 3 again, and you can see the steps I took there. I decided 2R1 minus R2, which is actually similar. Yeah. But then here I did R1 plus R3, because I can see I get rid of the x's in the third row. And then I combine R2 with R3, R2 minus R3, which is what I did in the last problem as well. I get -4, -8. And again, what you're doing is that you're, when you do 2R1 minus R2, you're multiplying this by 2, which I know is 2, 2, -2, and -4. I'm subtracting this with the second row here. That's why I get a 0. 2 minus -1 is 3. -2 minus 1 is -3. And then 4 minus 5 is -9. And you keep going, and then R1 plus R3, and then R2 minus R3. And even though, if you were to look at like some online resources or websites or a textbook on this stuff, usually, this is kind of the ideal solution. If you can get it down to all this, so you can just get X, Y, and Z straight up. But it's not necessary to get it down to that point because it takes a while. I think it's better just to, once you identify a simple equation with one variable, solve for that variable, and then you can get all the other variables. So it's kind of like all the dominoes fall. Once one domino falls, the rest all fall. And you get all the other answers here as well. Okay. Last page. So again, 3 by 3. Again, you have total freedom here. I decided to multiply R2 by 2, add R1. And then I saw there's an opportunity to get rid of the Y's and Z's. That's kind of creative. If I multiply R2 by 3 and R3 by -2, or by 2 and subtract, I can actually get rid of Y's and Z's. So therefore I have X I could solve, -17X equals -34. And then up above I have -6Y equals 3. That was also kind of nifty because I did 2R2 plus R1, which helped me get rid of the first and third terms, leaving me just a coefficient for Y, which is -6 equals 3. And then of course plug all into the second row, which is X, Y, and Z in it, but I already know what X and Y are, and I'm good. And Z is -1. So that's how that goes. There'll be another video lesson on day 2 of 6.2, and there'll be some special cases with that one.